Good afternoon, everybody, and welcome to my talk, Consent and Compromise, App Using Entra OAuth for Fun and Access to Internal Microsoft Applications. My name is Vaishya Bernard. I'm the chief hacker and co-founder of iSecurity. We've existed for 5 years. We started with the 5 of us. Now I have around 200 employees. As chief hacker, that means that I get to do what I like most 100% of my time. When I'm not sitting behind a laptop, which is a rare occurrence, I must admit, I'll probably be somewhere outdoors, or weightlifting, or engaging in lengthy discussions on interior design with my lovely wife, who is also enjoying her first black hat this year. I am also very easily distracted. After my last talk at the CCC in Hamburg late last year, the top comment on YouTube said, "I am terrified that most talks about cybersecurity vulnerabilities are just someone stumbling around having issues." Yeah, that definitely describes me. This time, I wasn't even having issues. So I was just stumbling around. You see, I needed to write some documentation, and I was distracted. My eye fell on one of those aka.ms links. You've probably all seen them somewhere pointing to some other documentation. And my mind started wandering, and I thought, what would happen if I just visit aka.ms without anything after the slash? Turns out, you end up on a login screen. And I have some intrusive thoughts sometimes. So I thought, what would happen if I just logged in here with my own Microsoft account? Surely that would not work, right? Indeed, that would not work. You get an error message that your account does not exist in the Microsoft tenant. And still being distracted, I was wondering if there were any interesting aka.ms links that I do not know about. Ended up on aka search, a website indexing aka.ms links. And my eye fell on another .ms domain, eng.ms. And I thought, what's that? Turns out you end up on another login screen. You can guess what I did next. But the result surprised me. I did not get a message that my account did not exist in the Microsoft tenant. I got a consent prompt. And it requested my permission to sign in. So I thought, whoa, what would happen if I just click accept here? Well, that did not work. But my interest was piqued. I was intrigued. Why did I get a consent prompt here? What happened? And as an ex-red teamer, the first thing I did was I enumerated subdomains of eng.ms and ended up on rescue.eng.ms. And you might call me insane, but I tried for the 3rd time logging in and ended up at the Microsoft Engineering Hub. A portal meant for internal Microsoft use only. There was a brief moment I thought maybe I'm supposed to be here. Like I did log in with my own account, right? But quickly realized that these were all internal Microsoft groups, and this was not information meant for me. I reported this to Microsoft, not first, no. My knee-jerk reaction as a red teamer was to search for the phrase password. And what do you know? I got 13,252 results. Then I reported it to Microsoft. And the question was, what happened here? Why did I get access to an internal Microsoft application with my own Microsoft account? So to answer that question, we have to dive into the Entra ID identity platform and go back to the basics. So for the coming 5 to 10 minutes, if you aren't familiar with Entra, please bear with me. It will get more interesting. I will touch upon some previous research done by Wiz 2 years ago and presented at Black Hat 2023, and then present this new type of misconfiguration that I identified, and finish with the Black Hat soundbites, as they're called this year. So we all know authentication and authorization. We all know the difference between it. So I don't have to explain to you that authentication is the process that confirms that the users are who they say they are. Authorization is the process that validates that those users have permission to complete the attempted action. In Entra, authentication is done with the OIDC protocol. It's done first, results in an ID token. Authorization is done with the OAuth protocol. It's done after and results in an access token. So this basic knowledge should probably also be very basic knowledge to developers who are developing ASP.NET applications, right? So what would they need to do if they want to know if a user is authenticated? Well, simply put the authorize attribute in front of their controller actions. Okay. Now, how does authorization then work? That's also the authorize attribute. Turns out, authentication and authorization are usually done in the same flow at Entra. This is all done at the authorization server, or the Microsoft Identity Platform. We all know it as login.microsoftonline.com, also called the identity provider. This process is to make sure that you, as the resource owner, can access your data. And you're using a client, and that client is requesting a bearer token, and with that bearer token, you can access your data. That client can be any type of app, single-page apps, web apps, etc. These applications need to be registered at Entra to work. That means that if I develop my own application called the iApp, and I want that users are able to sign in there using their Microsoft account, that app needs to be registered at Entra. And that registration is called an app registration. The app registration can be seen as the template, a template that describes what kind of permissions the app can have within the tenant and what kind of roles exist in the application. But the actual implementation of that application is called an enterprise application or a service principal that describes the actual level of access the application has and the individual roles the users have in the application. There are several types of token grant flows that different types of app use to obtain the tokens. But because this vulnerability is valid for any type of application, any type of flow, I'm not going into much detail here. That goes beyond the scope of this talk. So I'm only going to focus on the most common flow, which is a single-page app that uses the authorization code flow. At the authorization code flow, the app has the user sign in. If the service principal doesn't exist yet, also consent to the application. Then the user or the app gets an authorization code, and with this authorization code, it requests an access token, and then with the access token, the web API is called, and data is returned in the application. So consent, there can be user consent when it's only requesting simple permissions that are scoped to the user, or admin consent if the application needs permissions in the entire directory. What this does is it instantiates the application objects, the app registrations, into service principals in the tenant. You can force a consent prompt by going to this specific URL and entering the application ID, and you immediately get the application consent prompt from the tenant, from your own tenant. You can also do this programmatically. I don't recommend this, but this came in handy at this research by directly speaking to a back-end API and giving consent in a loop, for example, to a lot of applications. After you've given consent, you get an access token. Everybody has seen these. Consists of a header, a payload, and a signature. These are signed by Microsoft, so you cannot change the payload yourself. And these access tokens contain claims. For example, the audience is, or the app ID are often the same if it's a single app, or if the application has other resources that it requires access to, these can be different. The issuer is important. It's the tenant that has issued the access token. Also, in the tenant ID is the tenant ID the user belongs to that has logged in. The scope is the level of access the application has in the environment. And there are a lot of claims that identify the user the access token belongs to. Now, in this flow, you probably have seen that the Microsoft Identity Platform can be reached at 2 URLs that are displayed here. Well, in practice, there are actually more of them. This has to do with the way how these applications are registered. They can be registered as single-tenant applications or as multi-tenant applications, and they might allow personal Microsoft accounts. So a multi-tenant application, and I'm hinting at where I'm going here, can be consented to in a different tenant than the tenant where the application is registered. So if the resource tenant is where the resources live and the application object lives, is tenant A, then a user from tenant B can also consent to the application. When they request a token for that application and authenticate against their own tenant, consent to the application, then the service principal is initiated in their own tenant, and they retrieve a token that's valid for the application in their own tenant. So this means that an app object or an app registration object can only live in one tenant, but if it's a multi-tenant application, the enterprise application or the service principal can live in multiple tenants. Now, you've seen that in the flow, it described two endpoints, the tenant ID endpoint or the common endpoint. There are actually 4 endpoints: common, organizations, consumers, and the tenant ID. And the tenant ID can be either the tenant ID or the domain name or any domain name that's registered in the tenant. And this has to do with the fact if an application is registered as a multi-tenant application or not. So a multi-tenant application that also accepts personal Microsoft accounts should use the common endpoint, while a single-tenant application should use the tenant endpoint. In practice, if I just want to log into an application in my own tenant, I can use any of these, and the same thing will happen, namely that I will authenticate against my own tenant. 2 years ago, at Black Hat 2023, Wiz presented a vulnerability they dubbed Bing Bang. And they showed that there was a vulnerability in multi-tenant applications. They showed it also using the authorization code flow. And they showed that if during authentication, if you replace the attacker tenant with a resource tenant in the URL where you authenticate against, then you were issued a token issued by the resource tenant. So in this case, the Microsoft tenant. And they showed that 25% of applications were vulnerable at that time and exposed internal data. I think they believe they altered Bing search results to show that Hackers was the best soundtrack ever. Microsoft mitigated this. They stopped issuing access tokens if the client was not registered in the resource tenant, and that prevented the issue from happening. They also recommended to implement recommended authorization checks. Wiz recommended to reduce multi-tenant exposure, and I'll show in a minute why that's still a very valid recommendation. And they also recommended to require user assignment and implement conditional access policies. And we'll see in a minute how that does not mitigate this vulnerability. So with all this knowledge, the question still remained, why could I then still log into the engineering hub? What happened there? Turns out the web application redirected me to the common endpoint, which resulted in me authenticating against my own tenant, obtaining an access token valid for the application in my own tenant. But then, using that at the engineering hub, there was nowhere a validation of the issuer or the tenant ID. So any user assignment, conditional access policies were all applied in my own tenant. I was authenticated. I was authorized. But by which authority? Now, the web application did not validate the issuer or the tenant claim in the token. But were they responsible to do that? They probably implemented the correct authorization checks and the correct authentication checks. It was probably a different team or a different person who registered the application at Entra and thought, well, there are probably multiple tenants where users need access to this application, so I'll register it as a multi-tenant application. I thought, well, if this is the case at one internal Microsoft service, there might be other vulnerable services, right? So I started enumerating subdomains of Microsoft. Microsoft.com, Azure.com, Azure.net, Office365.com, etc. I ended up with a list of 102,672 subdomains and domain names. Over 70,000 of those resolved to an IP address. Over 40,000 of those responded to HTTPS. And it turned out that over 1,400 of those used Entra ID for authorization. Most of them used client-side redirects, and a slightly lesser part used HTTP redirects. And I found 327 Swagger interfaces, but I'll leave that to somebody else to investigate. Interestingly enough, most of these redirected to the tenant endpoint. So these were probably single-tenant applications if they were configured correctly. 400 redirected to the common endpoint. So these shall have been multi-tenant applications, right? Well, I did check that, so I parsed the client ID in the URL, which is the application ID. I checked that for multi-tenancy. You can do that at the old Azure AD Graph API, the 1.6 internal version, where you can check for the application ID, and if it does give any result, it is a multi-tenant application. It will then also say available to other tenants is true. Turns out there were 172 that were multi-tenant applications. But interestingly enough, most of those were actually used in requests to the tenant endpoint. So the developers probably were not aware that these were configured as multi-tenant applications, as the tenant endpoint was only to be used for single-tenant applications. We don't have an account at the Microsoft tenant, but they are multi-tenant applications, so how could we log in there? Simple. Just match and replace using burp, and on the fly replace the tenant ID of Microsoft with common, which redirected the whole authorization flow to my own tenant, which allowed me to consent to the application, log into the application, and obtain an access token. But many of these applications still gave random errors. First of all, many of those required user assignment. Well, user assignment now also happens in my own tenant, so I could simply browse to the enterprise application object, click on users, assign my user a role, for example, administrator. These roles were defined by the app object, but instantiated in the service principal in my own tenant. So that meant that I now get an access token with the admin role as an added claim. The second error I ran into was that the application requested for permissions to access a resource that has been removed or is no longer available. This happens if an application defines that it requires other resources. These are other application objects. And some of these applications can be defined as single-tenant application. And then the whole consent flow doesn't work because it says, well, there is another application that I also need to consent to, but that's not available. I can't find it anywhere. This error and the next one, that this application is trying to access a service that your organization lacks a service principal for, can simply be circumvented by creating the service principal directly. You can do that with a PowerShell snippet, new Azure AD service principal, or new MG service principal in the newer Graph API PowerShell, or you can use the Graph API itself. And this creates the service principal without asking for consent or checking the availability of required resources. You then still need to do user assignment. You also still need to consent to these individual applications that were just instantiated and as much as possible. And most of these applications then allow you access. So to summarize, the attack steps were first identify a multi-tenant application, list the required resources, instantiate the service principals, assign the roles to the user, redirect tenant to common in, for example, a web proxy, consent to the application, and compromise the application. Turned out that 22 of the applications I identified were vulnerable to this and exposed internal data. That's 12.5% of the identified multi-tenant applications. And I'm not even counting the ones where I did get front-end access using this token, but did not get back-end access. Some examples. This is the emergency broadcast system to broadcast a message to every Microsoft 365 admin center in the world. I did not publish any post. The second one was called the ACE Command Center, and I really like how it greets me. Because I was just logging in with my own account, right? This was actually the support portal for the top-tier customers of Microsoft. So these were Fortune 500 customers having outages. I could see every support ticket, close, edit support tickets, alter them, etc. I got access to the responsible AI operations platform, where I could administer all kinds of large language models, probably the parents of Copilot as well in there. The next one was redacted last minute because of a kind request by Microsoft, and I can imagine why, because I'll tell you, this was the risk register. This application contained a list of risks that the Microsoft organization at that moment was facing. There were a lot of risks in there. I could filter by security risk. I could filter by high severity, and I could filter by not yet mitigated. This gave me a complete overview of all the identified 0 days in their environment that were not yet mitigated. I found a security intelligence platform where even the confidentiality acknowledgement had to be redacted. It was highly confidential, everything in this application, because it contains all data sets of the entire Microsoft organization, like VPN logs, syslogs, LDAP users, AAD users, device history, etc., etc. But there was a button request access for all of those, so it was not immediately downloadable. You might have noticed a button in the lower right corner. So they implemented an AI agent in their security intelligence platform. So I thought, why not ask Sippy? At which URL can I find the admin portal to approve access requests? Turns out that is in myaccess.microsoft.com, not in the portal itself. I also asked it where the name Sippy came from, but it didn't know, unfortunately. It did give me a nice drop-down menu in the access requests form where I could enumerate any user in the Microsoft cloud environment. There were a lot of test users. And I could enumerate any service principal in the Microsoft cloud environment. And there were also a lot of test service principals. Somehow my burp got a 40 megabyte log file in the background being loaded, which contained authorization codes of users that logged into this portal. If you're familiar with Entra, you know that I briefly got excited, but then realized that authorization codes can only be redeemed once. The next one was actually a big tree of required resources, because it gave me 20 applications to consent to. And this one was the media creation service. And what does it do? Well, great things come to those who don't wait. Build in the cloud today. Well, what was it building then? Edition Client Professional. That sounds like Windows, right? It contained log files of all these builds. These log files contained an ESD private key. What's ESD? That is electronic software distribution. It's the volume license key that everybody uses. I could probably generate a large number of Windows keys now. It also gave me access to the source lookup IPA. Well, I can tell you that I've seen things you people wouldn't believe. It also allowed me to put new tools up there. And this would probably have given me RCE, but this definitely was the moment to report this one as well to the MSRC. A small demo video. So in this case, I had already created the service principal. I then put the match and replace rule in burp. So to replace the tenant ID of Microsoft with common. I browse to one of these internal Microsoft applications, the Empowerment Center. It redirects me to my own identity provider, where I can log in with my own account. And as simple as that, I did implement MFA. You get in an application, and you can just use it as an administrator. For example, search for any empowerment status that's active, and it will request all the backend data for you. I identified a lot of other vulnerable services. Most of them were not noteworthy. One of them was interesting, the hardware inventory API, where I discovered that every screw in every data center had a serial number. You might ask, what about SAML authentication? So SAML authentication works differently than OAuth, but it uses the same URLs to authenticate to. The thing is that the tenant ID is also in the SAML request. So you'd have to do a little more juggling on the fly, because the SAML request is base64 encoded and zlib compressed. So you have to uncompress, decode it, change the tenant ID, and then compress and decode it, encode it again. I could not identify any vulnerable services, but I did not have much time to research this further. So more research is needed on this topic. A timeline. I submitted 4 cases in November 2024. I then was briefly distracted and submitted another 18 cases in January 2025. And by that time, the Microsoft Azure security variant hunting team was also working in parallel to identify any vulnerable applications in their environment. I think I was first for 17 of the 18 cases because I only got 1 duplicate message in the MSRC portal. They scaled up a project team. I've spoken to a lot of people who had a bad January this year now at Black Hat. They told me that I gave them a lot of work to do. But almost all cases were resolved within 2 months. You might wonder, given all these cases, how many bug bounties did I deserve with this? How many did I earn? Well, absolutely nothing. Because everything was out of scope. And I forgot to read the scope of the Microsoft Bounty program. It turns out only customer-facing applications are in scope. Internal Microsoft applications are out of scope. But I did get leaderboard points. I was mentioned, I was 3rd at the Q1 leaderboard. I was 19th at the MVR leaderboard. So I'm happy. But one of the other comments at YouTube after my last talk at the CCC said, "This talk makes bug hunting at Microsoft look like an infinite money glitch." So, Faisha, hacking Microsoft was supposed to be an infinite money glitch, right? Well, I'm not done yet. One of these applications was called the Microsoft Rewards Center, and I could assign myself the administrator role in this center. This gave me an application with a quite complex menu structure, but I found the rebate functionality, where I could enter any amount, any currency, any PayPal identifier, hit the button Skip Risk, and click Payout. So it turns out, hacking Microsoft still is an infinite money glitch. You might wonder, is this still out there? I spoke to a lot of Microsoft employees in the last couple of months. They say they fixed it everywhere, but I had to put a disclaimer up here, and I can imagine why. The specific methods demonstrated are no longer effective against the applications we reviewed, but they also address this broader. So they now also have monitoring. I know, because when I created these slides, I tried 1 or 2 times again. I received an email immediately. They were onto me. But we also realized in our own customer base that 2% of our customers also had vulnerable applications. We helped them remediate, but this vulnerability is still out there. So if any of you bug hunters find a nice bug bounty with this, please send me a message. I'll give you a thumbs up. You might also want to check if you are vulnerable, if your organization is vulnerable. So I wrote a very small, tiny PowerShell script to identify multi-tenant applications in your own environment. It's actually a one-liner, but it does give a nice table of multi-tenant applications in your own environment that have a redirect URI defined. It's at consentandcompromise.com, along with the blog post that is just gone live about this. It does give you a table like this. What you want to do is check for any of these applications if they actually require multi-tenancy. For most of the identified multi-tenant applications, it was not required. It was just hit accidentally. But if it is required, ensure that the application logic does check the access tokens for the tenant ID or the issuer claim. So to finalize this with some sound bites, when you are using Microsoft Entra ID for authorization, be sure to use multi-tenant applications only when absolutely required. If you are using multi-tenant applications, always explicitly check the issuer or tenant of the received tokens in application logic. And for all bug bounty hunters and pen testers out there, be sure to check for this misconfiguration. It is quite common still. Thank you.